And welcome back. Now, to be quite honest, I'm a little bit tired today, so what I really need is a nice long deep sleep. It's the way I tell them. Yes, indeed. Now, this gamut here of wires and other bits and pieces on this ESP32 is for my latest project that I'm intending to implement, over the next 2-3 weeks. What is it? I want to have a big shout out for PCBWay, PCB prototype the easy way. Now, we all know about their PCBs, excellent that they are, but they also do, as you can see here, 3D printing look. And it's 10% off at the moment. Let's have a look what they do. Now, as you see here, this looks quite similar to the PCB upload screen. You just upload your file, probably an STL or something like that. Tell them what you want it to be made of, and it gives you such a wide choice here that you probably can't do on your own 3D printer. So I'm very tempted to try something like nylon or something, yeah. And you just upload it, tell them what you want, the color and so forth, and that's it. You submit it, get a request for a quote, and Bob's your uncle. And yeah, that's going to be my next step, I think. And don't forget, they also do flex and rigid flex PCBs. Now, these are really something quite special. If you need that sort of thing, you really need to look into it. It's great. For us hobbyists, standard boards over here, $5 for 10 pieces. How can you go wrong with that? I suggest we check them out right now. What is it? Well, it involves an ESP32 going to deep sleep for fairly extended periods. And what it is going to be is these two black bits here. This is a magnetic read relay here. So when I open this, i.e. this bit here gets screwed onto the door. When the door opens, this thing starts, and I think you might have seen a little flash on the LED there. And when the door shuts again, it does something else. And what is all this then? Well, it's a variation on the automatic start up and shut down circuit that I devised some time ago with an SI4599. This one at the back there, in fact, it's a dual MOSFET, very tiny. This one's on a little breakout board, so we can actually use it in a breadboard, which is great. Now, I'm going to screw this onto my door, and the idea being that when I open the door, the ESP32 wakes up and goes, "Ooh, I've been awoken by something. So I better go and tell the smart heater controller here in Ralph's workshop that somebody's opened the door." And if we have a heater on, say, in here, it's going to be extremely wasteful if that door stays open for any length of time. So the idea being that as it wakes up, it says, right, have I just woken up from a clean boot, as it were, a power on situation? If so, I'm immediately going to sleep for X seconds. Whatever time we determine will be sensible for me to think, I've opened the door, I've got my cup and plate maybe and a jacket and bits and pieces faffed about basically, and then maybe I've shut the door again. Well, that doesn't involve or require any kind of turning off of heaters or coolers or anything like that. But if the door stays open, as it does for hours on end in the summer, I hook it back on a stay, then after, let's say, 20-30 seconds, we'll determine this in real life when I finally get to implement the project. Say after 30 seconds, the ESP32 wakes up and it goes, "Oh, why am I awake now? Oh, it was the real-time clock that woke me up after 30 seconds. That means the door is still open." So the door's still open. It goes, right, okay, I'm sending out an ESP-NOW signal to the smart heater controller, say, "Oi, door's open. Do what you got to do." And that's it, right? Now, the problem there is, having sent out the message, what do we do with the ESP32 at that point? Well, we can put it back then to deep sleep, because at some point in the future, I'm going to shut that door again. And the ESP32 has got to wake up and tell the smart heater controller here, "Oi, he's shut the door now. You can go back to doing whatever you were doing, heating the room or cooling the room or whatever." So, yeah, it was tricky doing both those things, and I couldn't get my head around not putting the ESP32 in deep sleep whilst the door was open, even if that was several hours. I thought, surely this is going to flatten the battery in no time. And I mean, ESP32s are not well known for their deep sleep, low current consumption. Just as a comparison here, the Arduino chip, not the Arduino unit, obviously it's not designed to go into deep sleep as such, is it? You've got too many bits and pieces on there and LEDs and what have you. Well, a bit like this one here. Look, you can see there's an LED on there. Oh, it's just gone off. The Arduino chip, which is the ATmega328P, when that's in deep sleep and you've done it right with a proper circuit, as I did for my storage bin reminders, yeah, so as the storage bin goes up, the Arduino wakes up, sends out a message and then shuts down again. That goes into deep sleep around about 0.2 microamps. Yeah, it's mind-boggling how low. 0.2 microamps. I mean, the leakage current within the battery is going to be higher than that. So that's excellent. But the ESP32 can't manage anywhere near that. I mean, this actual module is not the one you'd use anyway, because as I just showed you, there's an LED on here. But even if you desoldered that, it'll still probably be, 5-6 milliamps, because there's loads of other circuitry on here. Yeah, you've got the USB to serial interface on there. You've got a voltage regulator. You've bits and pieces, yeah, that just would not do well in a battery situation. But there's hope in the form of a low power ESP32. I say low power, specifically designed ESP32 module. And that gets down to, well, it remains to be seen, but somewhere in the region of 15 microamps in deep sleep. That's 15 microamps. That's huge compared to the Arduino, but then of course the Arduino hasn't got Wi-Fi capabilities or anything like that, has it? Whereas this has. So I'm definitely going to need to use an ESP32, not an ATmega. And 15 microamps, well, let's go to the Oregon battery calculator to see how long that would last for. Okay, I've put some values in here, ballpark values really, just to see what it turns out to be. I've put in 1500 milliamps here. That's sort of, well, the least you'd expect from an 18650 anyway, which is what I might end up going with. But we'll put that in for now. 20 microamps I've got here for deep sleep. 50 milliamps when it wakes up. It'll probably be even higher than that actually with a bit of Wi-Fi. But the Wi-Fi I'm using is ESP-NOW, not true Wi-Fi. And it's all over and done with in a split second. How many wake-ups per hour? Well, it's not 5, but I put 5 in here for now. It's only during working hours. So let's assume, for example, that it's winter time. I'm opening the door, getting coffees, coming back in, going out for lunch, fussing the cat, whatever. Let's say 5 on average. Yeah? And it's waking up for about a second. Well, it's according to what you'll see in a minute, it's far less than a second, but we'll put a second. So let's have a look, see what that says. And it says there, estimated battery life is 1.63 years. Well, if I just get 0.63 years, actually half a year, that's good enough for me. So I think we can just stop the discussion right there, don't you? What? You got something to say about this? All right, comments down below, please. So I think, being sensible about it, I think we can say that an 18650 or other small-ish, 1500 milliamp hour battery pack would last forever. It would certainly last me through a season. So I'm not going to get hung up about that. I could, of course, have designed the circuit with 2 of these micro switch read relays, one to trigger it when the door opened and then it switches itself off, and then one when it closed and turned itself back on again, all with the use of this dual MOSFET arrangement. The circuit diagram, by the way, it will be a link for it will be down in the video description, but it's the same one we used in other circuits, variations of. But no need to go there, not with that sort of battery life. I think that's going to work well. Let's see this in action, shall we? Let me fire up a CoolTerm window, links down below for CoolTerm, and see what it says. Right, here we are then with the CoolTerm window open, nothing showing at the moment. I've connected it via the ESP32's TX pin, right, not the USB port, obviously, because that would power the thing up. So what I'm going to do is just open up the magnetic read relay, which you can just see at the bottom of your screen there. I know it's a bit cramped, but anyway, here we go. So I'm going to open up the read relay, which is like me opening the door. There we are, look, fires up, door opens and it says, right, we awoke not by deep sleep. It was basically a power up. So it's going to sleep for 10 seconds, which it did. It's now woken up again after 10 seconds. I know I said 30, but this is just for demo purposes, okay? And you can see here, look, it actually says deep sleep reset. So having woken up, it goes, well, I've woken up out of deep sleep, therefore you didn't shut the door because something else happens then, and the door's still open, so I'll pretend to do some work because it's not actually doing any ESP-NOW work at the moment. And it says, right, I've done the stuff I'm going to do, and I'm going back to sleep now, ready for you to shut the door. So right now, it's waiting for me to shut the door. There we are. So I'm now going to shut the door, or pretend to. Well, it all happened so quick. So it says here, look, it was a deep sleep reset, but the actual code says, look, it was an external GPIO signal that woke me up, which means it must have been door shut, because that's the only GPIO pin I'm monitoring. And it goes, okay, I've woken up, I've pretended to send out a signal back to the controller unit here to say door shut now, and then it powers down. And when it powers down to 0 microamps thanks to that dual MOSFET arrangement that I put together, must be 3-4 years ago now. And the reason I love it so much is because the SI4599, and there is an alternative to that, a drop-in replacement, not quite as high current capability, but for hobbyist use, we don't care whether it's 6 amps or not. It's just a dual MOSFET, one N channel, one P channel, and there is a very, very cheap drop-in replacement. All the details will be down below and in the GitHub. Anyway, what I like about it is because it's on such a tiny 8-pin chip, which you can see there. So it's a no-brainer to use that on a custom PCB. So now the door's shut by virtue of these two being close together. Oh, I've just opened the door according to the monitor. Let it go. Because it's now power off when I shut the door like that, power off entirely, absolutely power off, 0 microamps, not even 0.2. So it's actually better than the Arduino arrangement because we literally have powered it off. The only power potentially is going through the gate of the P channel MOSFET here, which will be in the order of picoamps. I mean, it's just, we're not even going to talk about it. It's so ridiculously low. And the battery would last literally forever. So the circuit's been tested to the nth degree. There's been about 3 or 4 variations of the circuit as I've tried to decide what to do. And I think we're there. So perhaps I ought to show you that circuit then and just talk you through it really before we come on to the code. So this is the final proposed circuit. We have a P channel MOSFET here out of that SI4599 dual pair. And this acts basically as the switch in the battery power track and the positive supply. So this is basically off most of the time by virtue of this resistor here biasing it off. When the gate here goes to ground or negative, power comes across this line here to the V out and therefore powers the ESP. Now of course as soon as power appears on here, it automatically via this 10k resistor powers the N channel MOSFET on, which then basically drags the gate to ground, so that when the micro switch has switched the gate on here but may at any minute disconnect itself because the door's been closed, the N channel MOSFET ensures that this latches itself on at all times. And the only way to turn it off now is for the ESP32 to sync the current here. So it's a GPIO pin set to output mode, but it actually conducts low, and the power then comes down here. And instead of keeping this switched on, it actually gets sucked away down here. That switches off, and therefore that switches off, and the whole circuit dies. The shut pin here is what detects when the door is closed, that as this switches over, this obviously gets connected to ground, and that interrupts the deep sleep on the ESP32. It's a really basic, simple circuit, isn't it? Right, this is the very simple proof of concept code really. I haven't productionized it yet at all. I've just got the thing working. And yes, it's written in Visual Studio Code with Platform IO, but it'll work just the same in the Arduino IDE. Remember that the ESP32 is a bit of a different beast when it comes to sleep and waking up. The Arduino, when it goes into sleep, suspends at a particular point in its execution. So the Arduino ATmega328P chip goes to sleep, and when it's awoken by whatever means, it continues with the very next statement. So the logic of your program is a bit different to what it is here in the ESP32, because the ESP32 basically starts afresh every single time. Now you might be saying, especially if you're a beginner to this deep sleep nonsense, how can you determine then what's going on if every time it wakes up out of deep sleep, it starts as though you've just switched it on? Well, let me show you that in just 1 second, all right? As part of the setup, it just defines a few pins, make sure things stay high and all that. But the very first thing it does is say, why have we woken up? Go and have a look at this bit of code here to find out why we've woken up. So I need to scroll back up because I've got the actual function up the top there. Right, here we are, wake on trigger, I've called it. So what is it that it does? Basically, it's an API into the ESP32 going, why have we just woken up? Why have we powered up? And the ESP32 will return one of these values here, yeah, starting from 0, 2, 4. And I'm only interested in 2 of those values, basically a power up, brand new, or because when the door shuts it brings a GPIO pin low, I'm also interested in this one here, which is EXT0. There's EXT0 and EXT1. I'll show you where you can read up about these, and there's other reasons why it might wake up, where you've touched something or the ultra low processor, power processor has done something. But that is how you can decide this ESP32 has powered up because one of those things happened. And normally, of course, in your code, it's always reason 0, which means I've just powered up, basically. Yeah, I haven't been woken up out of deep sleep. But in this case, we do definitely need to know that. And that changes the flow of the code. If you noticed on that circuit diagram, such as it was, there was in fact a mini state machine that I wrote there. Let me show you. So the state machine was basically, it starts up here. We start up with power up. We have a 30-second wait to go to the next state, which is confirmed that the door's still open. Then it just goes into deep sleep until we know that the door's shut. There's only 3 conditions and it's pretty simple. And yes, we can go directly from power up to door shut. Basically, if I open the door and then shut it immediately, we don't want it to do this bit here. We don't want it to confirm that the door's been open for 30 seconds because basically, well, it hasn't, has it, right? So we short circuit this and go straight from power up to door shut, in which case the ESP32 does nothing. It just wakes up, tries to go to sleep, but actually is triggered immediately by that pin and just powers down the end. So yeah, that's what the state machine currently looks like. So as the code shows you here, it says, why have we sprung up into life? Now you've got your 3 conditions there, if this, if that, and so on. Basically, we've already explained this. If the door's opened, it waits for a number of seconds to determine whether the door really is staying open or not. If it then wakes up and says, oh yes, the door has been open now for 30 seconds, it sends out the message to my controller. And when it finally gets the message to say the pin's gone low, which means the door's shut, it will send out another message and then just wait until the power goes off. I might change this last bit of code here, because what if the power doesn't go off? How am I going to know? The loop, you see, says, look, there's nothing to run the loop. We just can't get to the loop. Well, maybe I should allow it to go to the loop here to say, look, if we're running in the loop for more than a second, more than enough, something's gone wrong. It hasn't powered itself off. And maybe I need to know that. Talking of need to know and notifications, how do I even know this is working? That's the next thing. Now, as a notification mechanism, the beeper is well overused. And when I used it in my bin lid notification, it drove me nuts, beeping. It's just like, it's not a nice sound. It's quite harsh, isn't it? And I thought, well, in a car, if you have something go wrong with the car, you're driving along and, I don't know, there's frost or something, you get a very gentle sort of chime, don't you? Just bong. Well, it's probably not a bong, it's a chime, but you know, it's gentle. And even if you open the door with the key still in the ignition, you get a chime. It's much different to a harsh beep that switches on and off very abruptly. So I scoured the internet and I found this site. But there's probably loads and loads of sites like this out there. But this gives you an idea of the sort of sounds that we could implement as part of the notification that A, I've opened my door, and secondly, that I've shut my door, and then the power's been left on, something's gone wrong with it, say. You never know, you never know. Yeah, I know my code never goes wrong. It's the hardware that might go wrong, that's what I'm saying. I need to know that the factory hasn't switched itself off, otherwise that battery will go flat, of course. So I'm thinking, okay, all these sounds here then that we could listen to. Okay, that's a bit harsh. Okay, that could be a good one if the power's left on. Oh no, don't like that one. No. That's a good one. Door open, maybe. Oh, that one's a bit quiet. Bit in your face. Well, you get the idea, yeah? Good Lord. No, I'm not having that one. Okay, so there's all these sounds out there on the internet that I'm going to seriously think about using, believe it or not. I know this is over-engineering at its best. I have quite a few, actually, probably 3 or 4 MP3 players, which I've used in the past or something. I can't remember what it was. But anyway, an MP3 player, tiny little module. Ah, there it is. You put in a little SD card, of which I have several. Yeah, let's face it, to put a few sound modules, MP3 or WAV or something on there, is just, it's not going to take up any space at all. So, a 2 gig SD card, which is about the smallest you can buy these days, it's ridiculous, will be 1,000 times too big. But anyway, that's what I'm thinking of doing. And then what I can do is take, I don't know, let's say 20 sounds that sound okay, and have it randomly pick one. So when I open the door, I don't always get the same sound every time. So it might be a bing, it might be a bong, it might be a bing bing or something, whatever. Yeah, I'm sure you're getting the idea. So that I open the door, I get confirmation that the door's open and the thing is running. I need to know that the thing's running. And when I shut the door, ditto. It can find a random sound, not the same as perhaps that I used to open it. We'll see about that. And then should, of course, the power remain on for some hardware problem, certainly not software, oh, God forbid, I get notification like I just showed you, one of those up there. And yes, I know it's a little bit of overkill, MP3 player and a speaker and everything, but well, otherwise this project's pretty boring, isn't it? There's not a lot to it, to be quite honest. So I've mentioned a lot about the low current consumption in sleep mode for an ESP32, 15 microamps, thereabouts. So which one am I going to be using? And it's this one right here, a feather compatible one, pin arrangement. And that's winging its way from China, although the company itself I think is a Swiss company. But anyway, they source their stuff from China, so doesn't everybody? So if you think, for example, I should have approached this differently, I'd really, really like to know about it before I go much further with this project. So please, comments down below. And even if you think, yeah, that sounds fine to me, or you got questions about deep sleep or the auto on-off device, this one here, please, comments down below. I'd love to hear from you. And as you know, I answer all the comments. And if you found this whole video slightly entertaining or edutaining or whatever, do give me a thumbs up, because I like the hey, yay, oh, certainly do. And remember, to get more of these type of videos, you need to subscribe. And yes, you at the back, correct. You got to tick that notification bell, or you will never know about new videos that come your way. And I'm still working on the HTML part 3 for ESP32s. I'm almost there, but not quite. just putting the finishing touches to it, so it won't be too long. And until then, I'll see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.